to the mole and stoichiometry tutorial number 1. For this tutorial, you will need a periodic table and solubility chart, a calculator, the map of mole land, and the worksheet that accompanies this tutorial. This tutorial is intended to help you with basic stoichiometry calculations. So what we'll be looking at are if you're given moles or mass of one compound, to finding the moles or mass of a different compound. And so let's get started and take a look at what we need first in the setup of these problems. First, we have to have a chemical equation that is written and balanced correctly. So we have iron 3 chloride reacts with sodium hydroxide. So we need to write a correct chemical equation, and then we have to balance it. So there are sodium hydroxide and iron 3 chloride. Now, you have to take a look at this and figure out what type of reaction this might be so that you can properly predict the product. So looking at this, we have two ionic compounds. And so this is going to be a double replacement reaction where iron and sodium are going to swap places and form new compounds. So we have sodium chloride and iron 3 hydroxide. So now that we have our double replacement reaction completely written, we need to look at solubility. When chlorine is bonded with iron, it is soluble. When hydroxide is bonded with sodium, it is soluble as well. Chlorine with sodium is also soluble. And now here we have our precipitate. When hydroxide bonds with iron, it is still insoluble. Now let's take a look at this and get this balanced. We see we have 3 chlorines here. So let's go ahead and place a 3 in front as a coefficient for sodium chloride. And then we see we have 3 oxygens and 3 hydrogens. So we can place our next coefficient there. So now this equation should be balanced. We can look at our coefficients and see a few things. Remember, the coefficient represents the number of moles. And so we have 1 mole of iron 3 chloride reacting with 3 moles of sodium hydroxide to produce 3 moles of sodium chloride and 1 mole of iron 3 hydroxide. Now that we have our equation, chemical equation complete and balanced, we can move on to the next step, which is our mole ratio. And so the mole ratio is going to be fractions or conversion factors that we can use in the calculations that we make to go from one unit to the next. If you remember your map of mole land, this is going to be the mole ratio bridge, where you look at the number of moles of one compound compared to the number of moles of another. And so back here, we can make a few mole ratios. We can say 1 mole of iron 3 chloride over 3 moles of sodium hydroxide. So we have made a mole ratio between the two reactants. Now we can also do this between a reactant and a product. So we can say 1 mole of iron 3 chloride over 1 mole of iron 3 hydroxide. There are many more, but we are going to look at the problem next. And from that problem, we must determine which mole ratio we must use and set it up properly. So let's take a look at our first problem. Go now to number 3. It says to calculate the moles of iron 3 hydroxide produced by the reaction when starting with 0.75 moles of iron 3 chloride. So I hope you have your map of mole land out, and if so, you can look at it. We're starting with moles of one compound, which is iron 3 hydroxide, and we are moving to moles of another compound, moles of iron 3 chloride. Sorry, I had that backwards. Moles of iron 3 chloride to moles of iron 3 hydroxide. But we're going to use our mole ratio bridge to get there. So just to take a look right here, we're given this 0.75 moles, and we want to find the number of moles of iron 3 hydroxide. So let's have this set up, 0.75 moles of iron 3 chloride. And let's make a mole ratio. Now we see here there's 1 mole of iron 3 chloride and 1 mole of iron 3 hydroxide. And so now we have arrived at the unit that we want. We have our moles of iron 3 hydroxide, and we just have to make that calculation. So our moles of iron 3 chloride cancel out, and we are left with 0.75 moles of iron 3 hydroxide. So what we've done is we've taken the number of moles of one of our reactants, and we have found what will be produced, how many moles of iron 3 hydroxide are produced. Moving on to the next problem, problem number 4, if you're working this along with your worksheet. So problem number 4 says, what is the mass of sodium hydroxide, what mass of sodium hydroxide is needed to react completely with 10 grams of iron 3 chloride? So we are given 10 grams of iron 3 chloride, and we're looking at the mass of sodium hydroxide that's needed. Now if you're following along with your map of mole land, we're going to take a look at it right quick. Here it is. We have our mass of one compound. So we must first use our molar mass to find the number of moles of this compound. Then we can use the mole ratio bridge to arrive in moles of our desired compound, which is sodium hydroxide, and then use its molar mass to find the mass of that compound. So taking a look back here, we're starting with 10 grams of iron 3 chloride. So remember, first we have to use iron 3 chloride's molar mass to find the number of moles. So molar mass is something that we have learned before. You are finding the total mass of the compound by multiplying the number of atoms we have of each element by its atomic mass. So iron 3 chloride has an atomic mass that you can calculate of 162.3 grams per mole. So now that we are in moles of iron 3 chloride, we need to use our mole ratio bridge. You know we have 1 mole of iron 3 chloride for every 3 moles of sodium hydroxide. So now we are almost there. We have arrived in moles of sodium hydroxide. Next step is to find the number of grams. So once again, we use our molar mass, which is in grams per mole. And you can calculate sodium hydroxide's molar mass. It is 40.0 grams. And then you should be able to calculate this and arrive at your answer. Now, remember, we must also pay close attention to significant figures. Here we have 3 significant figures, and we will want our answer to have 3 significant figures as well. So you will have 7.39 grams of sodium hydroxide. So for this reaction to react completely with the 10 grams of iron 3 chloride, we have to have our answer of 7.39 grams of sodium hydroxide.